Welcome to this quick take video where we'll be discussing the new features in Vivado Design Suite 2018.1. There are several enhancements in Vivado 2018.1, and in this short video we will cover some of the highlights in different categories. Let's start by looking at the high-level enhancements first. In this release, no OS support has been removed compared to the previous release. Additional support has been enabled for Windows 10 Update v1803. And on the Linux side, Vivado 2018.1 introduces Red Hat, CentOS 7.4, SUSE 12.3, and Ubuntu 16.4.3 LTS support. Please refer to the 2018.1 release notes for the list of all supported versions. Vivado 2018.1 introduces support for the new Zinc UltraScale Plus RF SoC and Vertex UltraScale Plus HBM devices. There is also support for additional devices in the Xilinx cost-optimized portfolio of Spartan 7 and Arctic 7 devices. Additional devices are enabled for production in this release. These devices are from the UltraScale Plus family, as well as the Spartan 7 and Arctic 7 families. Additional information can be found in the 2018.1 release notes, licensing and installation user guide UG973. 2018.1 GUI offers more streamlined menus. The file menu is rearranged and subcategories were added to shorten and improve its logical organization. In addition, users can now easily access all GUI reports under the Reports menu. Tickle apps can now install and uninstall GUI custom command buttons. Two changes make this possible. First, Tickle commands were created to support adding and removing custom commands from the toolbar menu. Second, install and uninstall procs are now supported in Tickle apps. Combining these two features allows the user to create Tickle apps that contain custom commands. For partial reconfiguration and Tandem features, two new IPs have been introduced. PRAXI Shutdown Manager IP safely handles AXI interfaces on an RP to prevent system deadlock that occur if AXI transactions are interrupted by PR process. PR Bitstream Monitor IP can be used to identify partial bit files through the design flow for debugging and programming purposes. In addition, new device support has been added for partial reconfiguration, including RF SoC and HBM devices. Next, we'll look at the IPI and some of the IP enhancements. In IPI, several ease-of-use enhancements have been added, including the support for locking the placement of different elements on the canvas. With this feature, users can now prevent movement during schematic redraws by pinning down the placement of IP blocks, ports, and other elements onto the canvas as shown here. New Find dialog box allows users to perform detailed searches and use regular expressions to better traverse the design hierarchy. IPI now offers a way for selective upgrade of the IPs on the canvas. Users can now choose which IP to upgrade and when to do it based on their needs. In addition, IP Packager can now archive all sources used in creating a package IP, and preliminary support for System Verilog has been added in IP Packager. In verification IPs, new clock and reset VIPs allow different clocks and reset signals to be generated. These VIPs are unencrypted and based on System Verilog interface. Both VIPs support master and pass-through modes to generate clock and reset signals. Note that these verification IPs synthesize as wires. Moving to memory IPs, XPM FIFO now supports AXI stream and has an improved reset sequence to work under noisy conditions. XPM memory has increased the max memory size to 192 megabits that now matches the capabilities of block memory generator. For HBM devices, HBM is now supported in both IPI and RTL flows. In embedded IPs, we have area optimization for smaller switches in AXI Smart Connect, new AXI sideband utility IP, which can be used to add or recover the sideband signals on user channel. It supports parity and our master ID bits on the user fields. Added multi-SLR crossing mode for AXI4 stream register slice IP, and support for transfer sizes larger than 8 megabytes in AXI DMA and CDMA IPs. System Generator now has support for the MATLAB versions listed here. In addition, FFT, IFFT blocks in System Generator have been updated to use new logic core IP v9.1, and the corresponding example designs that use these blocks have also been updated. For Model Composer tool, which was launched in 2017.4, users can now view, analyze, and compare fixed point signals in the design. Integer overflow detection capability has been added for several blocks in the design using Simulink's data validity diagnostics. This detection enables debugging issues with integer overflows and choosing optimal data types. There is support for parameterization and function templates in C++ code import feature. Users can create custom Model Composer blocks through the C++ code import feature, and the new enhancements enable flexible and rapid exploration of data types and parameter space in simulation. Computer Vision Library in Model Composer now has 5 additional revision OpenCV functions. A new example design for motion detection showcases the use of blocks from Model Composer library as well as the custom C++ code import feature for building synthesizable designs. On the implementation side, there are several improvements for synthesis in Vivado 2018.1. The tool now infers finite state machines with don't touch or mark debug attributes. In addition, if there are user encodings in the RTL and there is a mark debug or don't touch, the synthesis tool does not change those user encodings. The next enhancement reduces the number of DSPs used by a design by folding a pair of DSP instances into a single DSP instance running at the 2x the original clock frequency. The immediate benefit of folding is that it reduces DSP utilization and therefore enables the packing of more logic into the FPGA. Additionally, for designs whose throughput is limited by DSPs, folding can increase throughput. The next capability is related to VRAM structures that could be subject to collision issues. As the synthesis tool automatically recognizes them, a new attribute can be set to let the tool automatically infer the extra glue logic to take care of the address collision. For implementation tools, here are the major highlights of the main features. 2018.1 focus is on improving the UltraScale Plus design performance and compile time, especially for congested designs. Compared to 2017.4, Fmax in 2018.1 is 6% higher overall and 13.2% higher on designs with routing congestion. When using the high-effort explore directives and strategies, Fmax is 3.3% higher overall and 6% higher on congested designs. 2018.1 has a substantially faster runtime compared to 2017.4, 12% faster overall and 73% faster on congested designs. When using the explore directives and strategies, 2018.1 is 23% faster overall and 62% faster on congested designs. The set of QOR suggestions has been expanded and refined. Following the generated suggestions could result in an average of about 4% Fmax improvement. In op design, new fine-grained optimizations have been added that allow pinpoint fixes of timing problems as an alternative to resynthesis. These include optimization of collapsing small lot chains, register chains, SRLs, and control sets. 2018.1 introduces implementation support for Zinc UltraScale Plus RF-SOC and Vertex UltraScale Plus HBM devices. For power analysis, XPE is capable to report total power and junction temperature of the FPGA device and the HBM stacks separately. As mentioned previously, SSI devices are prevalent in the UltraScale Plus family. A good portion of 2018.1 has focused on improving both partitioning and the placement of SLR crossings. There is now better out-of-box placement of SLR crossings to reduce congestion created during placement and new FizzOpt options that focus on improving SLR crossings exclusively to achieve fastest possible speeds. User SLR assignment attribute can be applied to hierarchical cells to first, preventing them from being split across SLRs, which might cause timing violation, and second, assigning them to specific SLRs without using P-blocks. These properties are soft constraints, that is, they are ignored if necessary to find a valid partition. A big change for UltraScale Plus is the ability to use both Laguna registers to cross SLRs. Previously, this was disallowed due to the possibility of unfixable hold violations. However, now the router can adjust clock leaf delays to fix hold. This should work for most single clock or intra-clock paths, but is not intended for use with clock domain crossings. For SDA, in 2018.1, there is an added GUI support for the report exceptions command that will allow the user to easily cross-probe the constraints from the exception report to the XDC file. In addition, report CDC -all checks per endpoint will generate all the violations for each endpoint instead of the highest priority violation per endpoint. To properly support various flows such as SDX and PR, the timing commands are now able to be scoped at the level of hierarchical module. The waiver mechanism is now supported in the methodology, DRC, and CDC reports. 4 new methodology checks have been added in areas including forwarded clocks, GT data rate, I/O registers, and path segmentation due to max delay data path only constraint. For simulation flows, we have added support for Cadence's new simulator, Excellium Parallel Simulator. This simulator is supported in both integrated launch simulation and standalone export simulation flows. Vivado Simulator now has 3 added new GUI windows to aid in step-through subprogram debugging. Call stacks window shows VHDL Verilog processes that are waiting inside a subprogram at the current simulation time. Stack frames window shows scopes, in other words, frames for VHDL Verilog subprogram. Any functions, procedures, and tasks which are in the call stack hierarchy for a process waiting inside a subprogram can be observed in the stack frame window. Local Objects tab in Object window shows the static and automatic variables local to the selected subprogram frame. For hardware debug, we have a couple of new features. First, generation and synthesis of debug IPs are done in parallel to improve the runtime. When IP generation cache is unavailable, debug flow now generates and synthesizes debug IPs in parallel. This enhances the existing flow by reducing the time it takes for implementing debug IPs. Next, the multiple or separate debug networks feature allows users to create physically separate debug networks in the design. With this feature, access to specific debug cores can be blocked or allowed. Primarily useful for data center applications, specific debug IPs will be visible to certain users while the rest are hidden. This feature is supported in both standalone and partial reconfiguration designs, as well as the XVC designs used for remote debugging. In summary, Vivado 2018.1 contains support for new devices including Zinc UltraScale Plus RF SoC and Vertex UltraScale Plus HBM devices. It adds ease-of-use enhancements in IP Integrator, supports new features in Model Composer, offers new IP and device support for partial reconfiguration, and improves UltraScale Plus SSI implementations and QR suggestions for implementation tools. Please review the Vivado 2018.1 Release Notes User Guide UG973 for more details on all the features and enhancements. Contact your local Xilinx representative for more details on Vivado Design Suite 2018.1 or go to www.xilinx.com/download to download and install it today. Thanks for watching.